Hello and thank you for watching. I have the pleasure today to talk to you about the Distributed Application Runtime, or in short Dapr, which provides us with a developer-centric approach to developing or creating microservice architectures. My name is Florian Asmus and I'm Chief Architect at PRODYNA. So let's have a look at the hopes and dreams when starting to develop microservices. I hope that I can gain speed in my development process and be more agile, so react quicker to requirements from my business and deliver value quickly. This is one of the major drivers for going into microservices. Also, reusing existing functionality or reusing services in new ways and in new context is a major benefit that I can get from having standardized APIs and having microservices that offer standards-based interfaces. Also, scaling. Scaling is a big issue with monolithic applications. They are hard to scale. In a microservice world, I have small little pieces and each of them is independent, hopefully stateless, so I can scale them on demand depending on the traffic of my users. One big issue a lot of big companies are facing with their monolithic applications is the maintenance of the code base in the long run. It grows, it becomes more and more complex. Onboarding new developers is virtually impossible because it has become so complex to understand all the repercussions. If I do this change, what will happen inside the code base? With microservices, we divide our functionality into smaller pieces, into smaller code bases that are very focused on a specific problem they solve, and with that having less code, more focused, and making it easier to understand. One last aspect is the possibility or the ability to experiment with new technologies, with new programming languages, new frameworks, new tools. Because each service is independent, I can try out new things a lot easier than in a monolithic world. But there is a but. Microservices are by design a distributed system. And everyone knows distributed systems are hard. Little example, this is the microservice network of the bank Monzo from the UK. They are running more than 1,500 microservices. They are all somehow interconnected. And as you can imagine, developing such a big system and with all these dependencies and all these interactions and makes it very, very complex to operate. And from a developer perspective, now that we have to develop a distributed system, there are a lot of fallacies that developers have in their mind when thinking about distributed computing. So first of all, the network, it's reliable, it's always there. I mean, we are in a data center, networks never fail. And also latency, it's so fast, that's not an issue. We can ignore it during development. I mean, in a monolithic world, this is totally true. I mean, we are running in the same process. Calling another method is typically not the big of a deal. But in a distributed system, there's a network involved, and it's a whole new thing. There are many other things that are misconceived or not realized by developers when creating a distributed system. Moreover, when we start to create such an architecture, we need some basic capabilities to support this. And number one is service discovery. So we need to somehow find all these little pieces. We need to know which IP addresses a service is running on, which ports, and so on. So having a centralized way of managing all these services and making them discoverable is essential. Now that we have a lot of communication going over network, we have to think about how we can secure it and how we can do these interactions in a very robust way. So we try rate limiting, encryption on the wire. All these things I need to solve when I really want to develop a distributed system. Dynamic scaling is one of the big promises that I get when starting with microservices. But how does this actually work? How can I, depending on the load, scale out my services, create new instances, and so on? I need a platform that supports this, and the overall architecture of my services need to be able to support this. So this is a capability I have to really build into the overall system from day one. Central management of configuration and secrets becomes more tricky because now all the services are running everywhere on different servers. So I have to find a way how to get this configuration into my services and provide them with secret information like database credentials and so on, or TLS certificates. Operational transparency also becomes a big issue because now everything is running all over the place. I need a single pane of glass to see what are my services doing, how do they respond to requests, when something fails, where did it fail. I need trace information, so I need to see which request went through this chain of different microservices. I need to access the logs of all the different services. So I need to do a lot of work to get this operational transparency into place. So there are many dark sides of developing microservices. So for one, the developer has to deal with a lot of new things, and it becomes more and more complex because now he doesn't only have to care about his code and his application, but he also has to care about infrastructure components, because now the network is part of the architecture, of the software architecture. For the operations people, we have a distributed system. We have many moving parts on different servers. So operating this in a reliable and efficient way is very, very complex and needs a lot of expertise. So developers have to learn a lot of new things. Operations leads to learn new things, and gaining this expertise while still remaining high velocity during development in the development cycle is something we really have to care about. Domain design becomes even more crucial in such a system, just because now the boundaries between services, there's network and there's latency and so on. So having bad domain boundaries means a lot of communication, meaning we have a problem. State management, so all our services or most of the services should be somehow stateless, and but we still have state of some kind, so we have to find ways to handle this in such a distributed architecture. Versioning, now everything is independently versioned, rolled out at different times, and making sure everything works together is a big challenge. And so on. Don't get me started on transactions in such an environment. It's a tough world. So when I want to do microservices, it's really, I have to think about a lot of things, and I have to deal with a lot of things I wouldn't have in a monolithic world. So let's see how Dapr, the distributed application runtime, can help to address a lot of these issues we have seen. So Dapr is described as an event-driven portable runtime for distributed systems. We will see in a second what this actually means. It is an open source project initiated by Microsoft. They are currently in the process of contributing the code base to the CNCF as an incubating project. And one of the main ideas is it uses this local development paradigm. So as a developer, I only develop against local hosts. In itself, Dapr provides different building blocks for common challenges I have in a distributed environment. So there are common things I need to solve. These are bundled into different building blocks, and for building blocks I can have different implementations solving this. So there is a huge set of implementations for different building blocks. Dapr is described as language agnostic, so it can be used with any programming language that can send and receive HTTP calls, basically, because Dapr is a runtime running next to my actual application or my actual services, and the interaction between the service and the Dapr runtime goes via HTTP REST. Or if I want to, I can also use gRPC. There are SDKs for all major programming languages, but essentially I don't need them. I can simply call HTTP endpoints on the Dapr process and interact with the runtime. So no real dependency to a specific programming language. On the infrastructure side, Dapr can run virtually everywhere. It's packaged as a container image, and it runs on a normal virtual machine or my laptop, or it can run in a large-scale production environment using Kubernetes, for example. So, as I said, Dapr has these building blocks, and for each building block, there are different implementations. Usually there is one implementation for each of the big hyperscale cloud providers, and a bunch of different implementations using open source technology. One thing that Dapr provides us out of the box for all these components and for all these building blocks is a rich set of telemetry or metrics, trace information, because Dapr knows about the interactions and is between our services and the interaction. So Dapr can inspect all the requests and interactions, and can send a lot of metrics out of the box. Security also a big topic. When using Dapr as a runtime, all the communication between the services is automatically, or can be automatically encrypted using MTLS. All the different services have identities, so I can I can write rules at the end which service is allowed to communicate with each other, and that's all based on service identity. So how does it work in practice? So first, let's take the simple thing, which is service-to-service communication, synchronous communication. So service A wants to call service B, both running on different hosts. So first of all, I need Dapr, distributed runtime, which means it's running next to each of my services, distributed across my whole architecture. So there is a sidecar. All of you that know Kubernetes know a pod can have many containers, and mostly there's one main container and the other one is some kind of sidecar, out of process extension. And this is exactly what Dapr does. It's an out of process extension. And now, if service A wants to call service B, it simply calls a REST endpoint on the Dapr sidecar. And that's the main difference to a service mesh. I mean, service mesh, hey, they are using sidecars and they are doing encryption and all this nice stuff. But service meshes like Linkerd or Istio are transparent. So the application doesn't even know that it's there. With Dapr, this is different. Now we are really programming against Dapr. On the one side, Dapr becomes part of our application architecture. It's our runtime. But on the other side, we get a lot of advantages out of this. Yeah? So service A calls simple localhost REST endpoint and calls a method. Dapr does all this service lookup thing and now calls the sidecar on the other side. And the sidecar for service B will take the request, forward it to a REST endpoint on service B. Response goes the same way. On the way, Dapr can do MTLS. It can send telemetry data. It exactly knows which service is calling which service. It has full visibility into the request. Yeah? And this allows us to implement a lot of monitoring observability features without having to do any work inside our service implementation. Yeah? So far, so good. I can do that with a service mesh, completely transparent. But what Dapr can do a lot better is tracing, because it has full visibility into the interaction and it knows the context. This is something a service mesh you need to put a bit more work in. But at the end, yeah, there's not much difference. But now let's have a look what Dapr can do more for. Yeah? Okay, I forgot there's access control, there are retries, all these nice little features. Nothing that you wouldn't get with a service mesh. But now, Dapr has a building block for state management. As I said, state management is a common problem when I develop microservices. I somehow have to manage state information, like user sessions or something like this. So Dapr has defined a building block for that. And I configured this building block using declarative configuration file. It's a YAML file. You all will feel at home when you love your Kubernetes configuration. Dapr looks very similar. And I configure my state store, and I configure it with a specific implementation. Like I have a Redis or a Postgres, a Memcache. There is a huge list of implementations for the state management building block. Yeah? Mostly the hyperscalers they provide some kind of native implementation, but there are also a lot of open source implementations available. The interesting part here is that my service A doesn't even have to know about the actual implementation. So there's no client library dependency in my code. I don't have to configure the connection string. I don't have to configure the credentials and so on. This is handled within the Dapr configuration. My service can now simply say, hey, I want to store state information in my state store with the key whatever. It's a key value store. And on the other side, I can simply consume this key. Both my services only call a REST endpoint. They have no clue of what implementation of a state store is behind it. And it could be even different environments, could use different implementations, completely transparent for my application. Then Dapr has a building block for implementing publish and subscribe. Common pattern, communication pattern, synchronous communication is in a large-scale system somehow problematic because we always have blocking calls. This accumulates over call chains. So I want to do a lot of things asynchronously and pops up. I can publish events. There can be many subscribers to these events, and they can do their work depending on the different events. So also there is a component configuration. So I configure my publish and subscribe building block, and I can use different message broker implementations. I can use NUTS, I can use RabbitMQ, I can use the Azure Service Bus, or whatever. So there are a lot of different implementations available. Same thing, no dependency inside my microservice. The developers can concentrate on developing their code and not having to deal with all this specific implementation details. Because all of these message brokers behave differently, work a bit differently, and with Dapr you get a common interface for doing publish and subscribe. Same goes on the other side, the sidecars from the subscribers. They are the ones connecting to the message broker. They are the ones receiving the messages and forwarding them to their actual service. So how does it work? As a developer in my microservice A, I can simply call localhost 3500, call the publish and subscribe endpoint from the Dapr sidecar, tell it which topic I want to publish the event on, and here we go. The subscribers receive the event and forward them to the actual service via a REST API. So when I now as a developer want to receive events from any of these message brokers, I simply define a REST endpoint and Dapr will call me if something is happening. So from a developer perspective, it's a huge relief and a lot of the complexity is now completely abstracted away into Dapr. And this is something you don't get when you're using a service mesh. Secrets management is also yes, when running in Kubernetes, you could simply use Kubernetes secrets and inject your credentials, or you could use one of the CSI drivers, but Dapr has something easily built into the runtime that works everywhere. So same pattern. I have a component configuration. I say, hey, Dapr, I want to connect a new secret store. It's based on HashiCorp Vault. or it's an Azure Key Vault, whatever, and I can access, I can configure how Dapr should access this key vault. When running in like the Kubernetes environment, I can use all these fancy things like pod identities on AKS or EKS, and this will also work with Dapr for accessing the actual implementation. For developer, don't care about it. The developer can simply say, hey, I want to write a secret or read a secret from this store with this key, and that's simply calling a REST interface. There are security mechanisms built in where you can configure exactly which service is allowed to access which store or even which key in which store. So you can really fine-tune so that that each service is only able to access the secrets that it should. Yeah? Oops. What you now can do is use also these secrets and combine them with the other building blocks. For example, for PubSub or for PubSub, you can use these secrets and reference them from other configurations. So you can inject like the credentials for the Redis or the credentials for the Postgres database from my key vault. So there is also an integration on this layer, which makes it easy to handle secrets all declarative inside the system. There are more building blocks like resource binding and triggers, which means I can listen on different resources if something happens, or I can send events or triggers myself to these applications. There's a wide list of supported triggers or event sources. You always have to look what source, if the source supports outbound or inbound or both directions. But have a look. There's a huge list available. There is a complete virtual actor model built into Dapr. So it's essentially a model where I can execute small pieces of work completely independently, and Dapr will do all the actor placement and so on. So all this management is done by Dapr. Observability is built into all of these components by design. Whatever these building blocks are doing, they always emit a lot of different metrics, and it's independent from the actual implementation you're using. So because Dapr abstracts this building block away, it can perfectly emit a lot of information about the system. Now, let's quickly have a look at how I can run Dapr. So when I develop my application, now that I have to call Dapr localhost, explicitly call it, I need the sidecar running on my machine. Yeah? It's very easy. There is a command line tool, Dapr run. I can run my application. There will be the sidecar next to it. It uses Docker to run a couple of infrastructure components or building block implementations using Docker, and with that, as a developer, I can quickly interact with the runtime even on my local machine, as long as I have Docker available. Then for a production environment where I want to scale my microservices and where I have a big mesh of all my different services, there is a deployment model where the Dapr control plane is running centrally. So there is a pod doing this Dapr runtime auto injection. You also know this from the service meshes. They do the same. So a new pod is created in Kubernetes, and automatically the Dapr runtime will be injected. So I don't have to specify all of this inside my Kubernetes deployment declaration. There's a security component that is responsible for doing certificate creation and distribution, so we can do all this MTLS and have the service identities in place. So a couple of components that run on the cluster and orchestrate the overall Dapr runtime, and then I have in each of my pods I have the Dapr sidecar. So as a developer, I simply can call localhost and interact with my state store, with my PubSub, with my bindings and triggers, and get all this observability without having to do any specific implementation in my microservice. So this is Dapr in a nutshell. I hope you got an impression of how it works, what it can do for you. It is available, I think, in version 1.3 now. So they are already on a 1. So general available, and really can be used in production environment. Yeah, I hope you enjoyed and have a great day.